Irodov question number 1.234. A thin uniform rod AB of mass m moves translationally with acceleration w due to two anti-parallel forces F1 and F2 as shown in the figure. The distance between the points at which these forces are applied is equal to A. Besides, it is known that F2 is 5 Newton. Find the length of the rod. So, this is the first of rotational dynamics problems. It's a simple one. Let's start with the diagram first. Okay. So, there are two forces. These are anti-parallel forces on this rod acting at a distance a to each other, and the question is to find the length of the rod. Okay. It mentions that this rod moves translationally with an acceleration w. So, first of all, when the problem says that the object is moving translationally only, so which means there is no rotation. So, it has rotational equilibrium. And what does rotational equilibrium means? It means tau, let's say about the center of mass, is 0. Okay. All right. So, how do we calculate tau? The torque tau c will be torque due to F1 and torque due to F2 about c. Okay. In fact, if it is in rotational equilibrium, the net torque acting on the system will be equal to 0 about any point. Okay, but conveniently we can take torque about the center of mass. Now, let's say the length of the body is L, then this distance is half of L, because center of mass will be midway. Okay. So, now we can calculate torque due to F1 is F1 times L by 2, and it is trying to turn it this way. Let's say this direction, which is anti-clockwise, we take the torque as positive. F2 will try to turn it the other way, clockwise. So, it will be minus F2 times, what is the distance? The perpendicular distance from F2 to the center of mass is L by 2 minus A. L by 2 minus A. So, this should be equal to 0. Okay. So, from this we get one relation. The relation is F1L minus F2L plus 2F2A equals 0. Okay. So, let us say this is equation number 1. Second thing, this is moving translationally, it is not in equilibrium. So, let us say it is moving towards this direction with acceleration w. So, F2 minus F1 net force acting on the body will be equals to mw. The value of F2 is given, value of F1 is not given. So, let us just find out F1 from here. So, it would be F2 minus mw. Okay. This is equation number 2. Okay. So, if we substitute value of F1 in this, so that becomes F2 minus mw times L minus F2L plus 2F2A equals 0. So, F2L minus MWL minus F2L plus 2F2A equals 0. F2L we can cancel. So, MWL is equal to 2F2A, or L is 2F2A divided by MW. Okay. So that is our answer. So this is a very simple problem and that's our solution.